This video is over lesson 81, solving inequalities with variables on both sides for my Algebra 1 class. And so you might want to take a moment and pause the video and copy down what we see here. So, ladies and gentlemen, we've actually already gone over this, but I just want to highlight it here. Literally, we're going to highlight it just to review. So if we have, remember when we read this, we read if A is greater than B, we should really be reading this as if we have an inequality. That's really the purpose of this statement. Because while it does say A is greater than B, we can likewise say B is less than A. So we can treat this going either way, really. So remember, ladies and gentlemen, when you see these in formulas in the future, that's how you need to be thinking about them. If A is greater than B, then A plus C is greater than B plus C. So remember, if we add something to both sides, it doesn't matter what that something is. That something could be positive, negative, or zero. Doesn't matter. It'll still be the same inequality symbol. For that matter, if we subtract C on both sides, same inequality symbol. Now, when it comes to multiplication and division, if we multiply both sides or divide both sides by the same number, and that number happens to be C greater than 0. So in other words, if C is greater than 0, this means that C is positive. Then the symbol will stay the same. However, if that's something we are multiplying or dividing by, that C is less than 0, in other words, C is negative, then the inequality symbol will flip on us. So we have to keep that in mind as we're doing anything with inequalities. So with that out of the way, let's go ahead and take a look at our first example together. So I have 2x plus 7 is greater than a negative 5x plus 21. Now, ladies and gentlemen, remember that inequalities solve basically exactly the same way that equations do. And as I've said in class, I've highly recommended, and I would like you to follow this, please. Take care of your x values first. Okay, so if you've got x values on both sides, take care of those first before you start taking care of your constants. I'm also going to take this moment to remind you, if there's anything you can simplify, like combining like terms, distributive properties, those all come first. Then we're going to start subtracting and adding on both sides. So since there's nothing I can simplify here, I'm going to go ahead and move on to my addition and subtraction. That's where I'm going to cancel out this negative 5x. I like canceling this out because remember, what separates terms is addition and subtraction. So we'll cancel them as addition or subtraction. And so to cancel out a negative, I'm going to add 5. We like working with positives. So I'm going to add 5x. Oops, fix my line up there just a little bit. That's better. And now let's simplify. So 2x plus 5x is a 7x plus 7 should be greater than, and then those just canceled, so plus 21 or positive 21. If we keep going now, I can subtract 7. So I'll keep going with my addition or subtraction. Subtract 7 there, so a 7x then should be greater than 14. Finally, divide both sides by 7, and x should be greater than 2. Now, I'm going to go back on this one just a little bit. I want to go back to this line right here and just look at a different way that we could have solved this guy. Now, generally, ladies and gentlemen, when we're solving equations or inequalities, we follow SADMAP. However, that is the general rule. There are things that allow us to break the rules. One of the things that allows me to break the rules of both the order of operations and SADMAP is the distributive property. So here, instead of doing my addition first and then taking care of my multiplication, I can take care of my multiplication so long as I use the distributive property to simplify it correctly. Remember, we always do everything to both sides. So when I divide by 7 here, it's the entire side that is over 7. Now that 7 will distribute to the 7x and the 7. So 7x divided by 7 is x. And then be careful here. I get a lot of students that want to just have these cancel. Okay, but you've got to think about what do they cancel and become. My negative 5x and my positive 5x cancel to become 0. And it was a 0 plus a 21 that results in just a 21. A plus 7 and a minus 7 cancel to become another 0. 7x plus 0 is just 7x. Down here, this 7 and that 7 do cancel, but what do they become here? They become 1s. So 1x over 1 is just x. So over here, when I cancel a 7 divided by a 7, these are 1s. So this is going to be a 1. Often I see students make the mistake of just canceling the 7 and just having x. Okay, that would be incorrect. So on the other side we have 3. And now obviously we subtract 1 from both sides. And x is greater than 2 still. So either one of these options works perfectly fine here. Just make sure that if you don't follow SADMAP completely, that you make sure to simplify correctly. For our next example, we're going to take a look at a negative 5b over 8 plus 5/16, and that will be greater than or equal to b over 8 minus 9 over 16. So here we go. I like the idea of adding and dealing with positives. Positives are just generally easier to deal with. We tend to make less mistakes when we're dealing with positives. So I'm going to do that here. I'm going to add 5b over 8 to both sides. Now, ladies and gentlemen, you cannot forget the rules that you've learned all along throughout your math career. What has always been true is still true. In order to add fractions, we need to have common denominators. Well, that's no problem here. An 8 and 8, common denominator, so this is just b plus 5b. So combining those like terms, this will be 6b over 8. Now, if you really want to reduce that down to 3b over 4, you can do that. I'll just save it for the end, though. Copy the rest of the problem down. Now, we're going to go ahead and continue with our addition and subtraction. That part is SADMAP. So now I want to get b by itself, so I need to get rid of this 9/16. So we're going to add 9/16 to both sides. And so 5 plus 9, is 14/16 is greater than or equal to 6b over 8. And then finally, to finish this off, in order to get rid of the 6 and the 8, just treat this like a 6/8 multiplied by b. So in order to cancel out that 6/8, we would then need to multiply both sides by its reciprocal. So I'm going to have 14/16 is greater than or equal to 6b over 8, and then multiply both sides by 8/6. So we know over here this is just going to simplify to b, because the 6 and 6 will cancel, the 8 and the 8 will cancel. Over here, I'm going to do a little reducing before multiplying. So 8 and 16 obviously can reduce to a 1 and a 2. 6 and 14 can reduce to a 3 and a 7. And so that simplifies down to 7/6. Now, generally speaking, we don't like mixed numbers except for final answers. So I'm going to move on to my final answer here. We also tend to like the variable on the left side of the inequality. So I'm going to move the b over here, but when I do that, not only is the b going to flip sides, but the way our inequality is pointing is going to flip with it. So this will become b is less than or equal to, and then 6 goes into 7 once with 1 left over. So 1 and 1/6. b is less than or equal to 1 and 1/6. Now, ladies and gentlemen, I'm going to do this one more time with you, but I want to do it slightly differently, because while this one was purposely designed to be fairly easy to deal with the fractions, the reality is many times we're going to come across inequalities that just won't have nice fractions. Not that you can't work through it, but just not as nice. It's going to be a little bit more thought intensive to work through it. So one of the techniques that is just really helpful is to get rid of the fractions. So noticing these have denominators 8, 16, 8, 16, we think of what would be a common denominator for all four of those. Well, obviously 8 and 8 are the same, 16 and 16 are the same. So between an 8 and a 16, easy common denominator, 16. So what I'm going to do is I'm going to take this and I'm going to multiply both sides by that common denominator, that's 16. And so when I distribute the 16 in, it's going to go to both of those terms. So when it goes over here, the 8 and the 16 will reduce. So the 8 will be gone, but there'll be a 2 left over. So 2 times negative 5b would be a negative 10b. When I distribute the 16 to this fraction, the 16s would cancel, leave me with just plus 5. When I distribute this 16 to this fraction, the 8 and the 16 would reduce. The 8 would disappear. The 16 would become a 2, so 2 times b, or 2b. And then finally, when I distribute the 16 to this fraction, the 16s would cancel, leaving me with just a minus 9. And now if you consider solving this inequality, this actually does look a whole lot nicer than trying to solve this guy. So if you feel like that'd be helpful, please take this route. It is one more step, but it's a step that can save you from making some mistakes. So here we go. This time, I'm gonna say I want my variable on the left. It's nice to have positives, but I'm gonna say let's just have the variable on the left this time. So I'm gonna subtract 2b. So to cancel out a positive 2b, we subtract 2b. So a negative 10b minus 2b is a negative 12b, plus 5 is greater than or equal to a negative 9. Then from here, I'm going to subtract 5 on both sides, so that a negative 12b is greater than or equal to a negative 14. And then finally, I'm going to divide both sides by a negative 12. Now, I haven't been talking about this so far. This is the first time that it's come up. But remember, ladies and gentlemen, that we do have to be keeping track of when our symbol is going to stay the same and when it's going to change. So far, we've only added, subtracted, or multiplied or divided by positives. So adding and subtracting, symbol always stays the same. Multiplying or dividing by positive, symbol stays the same. But this time, we are dividing both sides by a negative. That means that this symbol will no longer stay the same. So b will be less than or equal to, and then if we take a look at this guy here, negatives will cancel. 14 over 12 reduces to 7 over 6, which is 1 and 1/6. Same answer. Just one extra step. So, ladies and gentlemen, be careful when you're solving these to consider, am I multiplying or dividing by a negative? I'm going to go on to the back for our next example. I encourage you to do the same. I imagine you're getting pretty close to the bottom of your paper. And we're going to need a bit of space. So for our next example, we're going to take a look at 2 times the quantity x minus 8 minus 3x greater than 6 minus 3 times the quantity 2x plus 4. Now, if you're feeling pretty good about this, go ahead and pause the video and give this a shot. See if you can, if you listen carefully, if you can go through and get the answer on your own. All right, let's take a look now. So, first things first, if you listen to what I said earlier in the video, you need to simplify first. So I'm going to take care of my distributive property here. So 2 times x will give me a 2x. 2 times a negative 8 will give me a negative 16. Now this minus 3x is outside of the quantity, so it is unaffected by the 2. Now since all I'm doing is simplifying, the symbol's not going to change for simplifying. On the other side, 6. Here though, hopefully if you've done this on your own, you caught and you remembered, anytime we have a minus, we need to think about this as a negative. So this is not just minus 3, this is like a negative 3 that will then get distributed. So when a negative 3 gets multiplied with a 2x, we get a negative 6x. And when a negative 3 gets multiplied with a positive 4, we get a negative 12. Now, continue to simplify. So I can combine like terms. I got my 2x, I got my minus 3x there. So 2 minus 3 gives me a negative 1, or just negative x minus 16. Again, we're still just simplifying, so symbol stays the same. On the other side, I have two constants. So my negative 6x, remember treat the minus like a negative. My minus 6x will be my only x term there. But a positive 6 and a negative 12 results in a negative 6. And then we solve. So with x's on both sides, resolve your variables first. Take care of them first. So I can either add x to both sides, or I can add a 5x or 6x to both sides. I like the idea of adding 6x to both sides here for 2 reasons. One, because then we'll be dealing with a positive 5x over here. And 2, because the x will be over here. We like the variable on the left at the end. So that kills 2 birds with 1 stone. So that gives me my 5x minus 16, which is greater than, because addition doesn't change the symbol, negative 6. I'm going to continue with my addition and subtraction. I'm going to now add my 16 to both sides. And so 5x then must be greater than, because we're adding, the symbol won't change. A negative 6 and a positive 16 gives me a positive 10. Now, divide both sides by a positive 5, and since it's positive, the symbol will stay the same, and we get x is greater than 2. All right, and here we go. Moving on, we've got 2 more examples to look at, and they're going to be the trickiest 2 examples of the lesson. So, our next example will be 3x plus 4 minus x is greater than 2x plus 7. Now again, if you're feeling pretty good about these, don't be intimidated by what I said just a moment ago. Go ahead and pause the video and give it a shot. If you make a mistake, we learn from our mistakes. The worst thing you'll have to do is maybe do some erasing. So I encourage you to pause it and give it a shot. All right, here we go now. So for this, I'm going to simplify first. So a 2x and a minus x will leave me with just a I'm sorry, 3x and then minus x will leave me with 2x. And on the other side, nothing to simplify. Now, you've got constants on both sides. You've got variables on both sides. Take care of your variables first. So I'm going to cancel out this positive 2x by subtracting 2x on both sides. And so that leaves me with 4 is greater than, 7. And that's it. The variables are gone. So with the variables gone, we need to take a look at this and think about the truthfulness of this statement. So, is this true? Remember that to be a solution to this inequality, it needs to be a value or values that make the inequality true. So, but as we solve it, the whole point of solving it is, like if we go up to this one, the whole point of solving this is that whatever makes this true also makes this true, also makes this true, also makes that true, also makes this true, also makes that true. And so if we want to know when is this true, it's true in the same places that that's true. That's the point of solving this. This is a simpler way of understanding where this is true. So this is true for whatever x values make this true. So if x is 1, is 4 greater than 7? If x is negative 5, is 4 greater than 7? If x is a negative 17 over pi, will 4 be greater than 7? And hopefully the answer that you're coming up with every time is no. This, excuse me, is never true. It will never be true. There is no value of x that will ever make this true. Well, if there's no value of x that will ever make that true, then this is never true. And so therefore, what solution is there? None. So when it comes to solving inequalities, if you run into a situation like this, where this just cannot be true, then it's never true. All right, let's take a look at one more here. And we're going to do 3 times the quantity 2y minus 6 is less than or equal to 6y plus 4. All right, and if we go ahead and solve this one then, first of all, simplify. So I'm going to distribute my 3. So 3 times 2y is, oops, excuse me, got the 3 stuck in my head there, 6y, and 3 times a negative 6 would be a negative 18. So negative 6, or 6y minus 18 is less than or equal to 6y plus 4. So deal with your variables first. So I'm going to cancel out this 6y by subtracting 6y on both sides. And so a negative 18y is less than or equal to a positive 4. So consider this one here. Is a negative 18 less than or equal to 4? So whatever values make this true also make this true. So if y is 1, is negative 18 less than or equal to 4? If y is negative 4, is negative 18 less than or equal to 4? Well, since there is no y value here, the y value can be absolutely anything, and either this is true or it's not. Just like up here with no x value here, the x value doesn't affect this. It just is true or it isn't true. So down here, is this true? Yes. And so if this is true, it is always true. And apparently I'm having trouble writing the word true today. I keep wanting to skip that R. And if this is always true, then up here, that means that this, no matter the value of y, is always, I did it again, is always true. And therefore, what value will make this true? Well, all real numbers will make it true. It is always true. Doesn't matter what you plug in for y, it is always true. And that, ladies and gentlemen, is the end of our lesson.